Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to be solving two-step equations. All right, my friends, so before we get going, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. We're in volume 2 now. Second, you're going to need your math notebook so you can take those beautiful notes. Third, don't forget your pencil. And fourth, last but certainly never ever least, that positive math attitude. All right, my friends, so this video goes really well with lesson 5-2 in your Envision, of course, and the key concepts can be found on page 272. Now, if you remember in our last lesson, lesson 5-1, we just learned how to write these two-step equations, right? So we read some information, then we translated it into some math talk, right? Well, what we're doing here, my friends, is we're actually going to solve, which is super duper exciting. So the first problem that I would like to look at together is actually example number 1. All right, my friends, again, this is example number 1 on page 270. So we have Nala and 2 friends spent $21 on movie tickets and a box of popcorn. How can you find how much each movie ticket cost, right? So let's put aside the fact that $21 for 3 people and popcorn is a screaming deal, not super duper realistic. Let's set that aside. But how can we figure this out? So if you look at the picture on that page, it actually tells you how much the popcorn costs. And we know how much they spent all together. And then it's showing this weird bar thing. What's that called? Oh yeah, it's a bar diagram. So let's add some more information here. So first, what I know from that picture is that the popcorn cost $6, all right? I also know that the whole entire amount of money that they had to purchase or they had to spend was $21, okay? So this first long rectangle or this first bar that I drew represents our total amount, the whole amount that they actually spent, which was $20. Now, what went into that $20? Well, there was the popcorn, so let's represent that piece. So we know that the popcorn cost $6. Again, that's from that picture, right? Now I want you to notice that I drew that $6 underneath that 21. Why? Because that $6 helped make up that total of $21. But did they just go to the movies just to get popcorn? No, of course not. They also had to buy those tickets. And how many tickets did they purchase? 3. But that's our unknown piece, right? That's what we're going to try to figure out. So how can we represent that there was 3 tickets that when added to that $6 made up that $21 as their final cost of the movies? So we can represent the 3 movie tickets by using M. I'm using M for movie tickets, right? That's just a variable. It's standing in for that amount that we're not quite sure about yet, right? But here's what this picture means, my friends. That we had 3 tickets, right? 3 movie tickets. Movie ticket 1, movie ticket 2, and movie ticket 3. And those are the same amount, right? And then when I added that $6 popcorn, that gave me a total of $21. Now our quest, our math adventure, if you will, my friends, is to figure out, well, how much did each individual ticket cost? So let's think about it this way. In order for me to figure out what M is, I need to isolate it. What I mean by isolating the variable is I want to keep it by itself, right? So in order to do that, let's take that popcorn away and see how much money they spent just on movie tickets. So now I've updated our bar diagram with some more information. So that $6 for the popcorn, you'll notice I crossed it out because I'm subtracting that amount, right? So we had $21, which was our complete total, but what I did is I took away that $6. And that means that we spent $15 on movie tickets. More specifically, that means that when I added this movie ticket, plus this movie ticket, plus this movie ticket, the total was $15. I can rewrite that like this. So what I did is I just pulled this information out from my bar diagram. And I know that M plus M plus M equals 15. But hey, repeated addition can just be written as multiplication. So I essentially had 3 M's, and that gave me a total of $15. But remember, I want to isolate that variable. I want to get it all by its lonesome. So what do I need to do? Well, I need to undo multiplication. And how do you undo multiplication? Well, you need to do the opposite of multiplication. And the opposite of multiplication, or the inverse operation, if you will, is division. So what I'm going to do is I need to divide this side by 3, as well as this side by 3 as well. And that will tell me what m is equal to. So once we isolate the variable, we know that m is going to be equal or the same as 15 divided by 3. And we are also smart and beautiful and brilliant that we know that then m would equal 5. Now let's take this $5 and see, does it make sense in our original diagram? So now what I've done is I've gone back to our original bar diagram and I've plugged in the information that we now have. So again, the total amount that they spent at the movies was $21, all right? They spent $6 on popcorn, and we know now that the tickets were $5 a piece. So now, in theory, my friends, when we add up $5 plus $5 plus $5 plus $6, that should get us 21. Let's check. Well, 5 plus 5 is 10, plus 5 is 15. 15 plus 6, let's see, 15, 16, 17, 18, 19, 20, 21. It works! All right, so the next one I'd like to look at together is number 6, and this is on page 273. Now again, we have a bar diagram, all right, which is this lovely illustration Mrs. Schlecht put right here, okay? Up above, you'll notice that we have the algebraic equation that represents this picture, right? So essentially, my friends, what we have is I have 4 x's, 1, 2, 3, 4. And when I have those 4 x's, but then I subtract 12, that's why our 12 section, I put some lines through it because we're going to be taking that piece away. The answer is 16. And what we want to know is, well, what are these x's, right? So let's think really quick. 4 x's, that was like our starting point. And what that was, is that was before we subtracted 12, right? So I'm curious, my friends, what would this whole bar represent? Well, in order to figure that out, we would need to know, well, what's 16 plus 12? Hey, we know that 16 plus 12 is 28. That means that these 4 x's, that was again like our starting point, that was equal to 28. Now, how can we figure out how much each of these x's were? Well, let's look at some numbers and see if that will help us make sense. So we know that 4 x's, x plus x plus x plus x, that needs to be equivalent or the same as 28. And we also know that, hey, repeated addition is the same as multiplication. So we could also just say that 4 times x, that equals 28. Now, just like we did that last problem, my friends, I need to isolate this variable. I want to make x all by its lonesome. So if I use multiplication, if I multiplied by 4 in order to get 28, how do you undo multiplication? Well, you divide, right? So if I want to undo multiplying by 4, what am I going to do? We're going to divide by 4, right? So to undo that multiplying by 4, the opposite or the inverse operation of multiplying by 4 would be dividing by 4, right, my friends? Remember, we have to do that to both sides of our equation to make sure that it, stays equal, okay? So I know we're going to put it over here. That x would then equal or be the same as 28 divided by 4, and we know that then x is equal to 7. Now, let's plug 7 back into our original bar diagram and see if that is correct. So now we have, instead of our x's, instead of those variables, we know now that the value of that was actually 7. So if I do 7 plus 7, that's 14, plus 7, that's 21, plus 7, hey, 28. Now, let's put this in the context of just our algebraic equation. You'll notice our bar diagram, it's gone, right? Let's just focus on our numbers and our symbols and this lovely algebraic equation, okay? So we have 4x minus 12, that equals 16. Now remember, our goal is to isolate that variable, right? So anything that was done to this x, we essentially need to undo all of it, okay? Now you'll notice that we subtract that 12, right? So I want to undo that part first. So what's the inverse operation or the opposite of subtracting 12? So the inverse operation of subtracting 12 is adding 12, right? Remember, we're going to do that to both sides of our equation to keep it equal, okay? So if I subtract 12, but then I add 12, I drew a line through it because that's going to cancel each other out, right? So then over here, we'll have 16 plus 12. Ooh, what was 16 plus 12 again? 28, right? Very nice. So instead of having 16 plus 12, we're now just going to write the new value, which is 28. All right. Remember, we have to bring that 4 times x or 4x down because we haven't got anything to do with it quite yet, right? We can't just ditch it because we still got to do stuff with it, okay? So now we know that 4x, 4 times x, is the same or equivalent or equal to 28. Now remember, if I used multiplication to get 28, how do I undo multiplication? We're going to use division, right? So to undo multiplying by 4, I'm going to divide by 4, right? Now, if you multiply by 4, but then you divide by 4, that cancels each other out, right? And then we're left with just x is equivalent or the same as 28 divided by 4. How could I represent that? So we could say, because remember, we're trying to isolate the variable. We're trying to make it all by its lonesome, right? And now I have it here. So x is equivalent to 28 divided by 4. And we know that, hey, 28 divided by 4 is just 7, right? So that means that x equals 7. All right, my friends, that was just a quick run through over lesson 5-2 in your Envision book, which helped us figure out how to solve two-step algebraic equations. As always, if you have any other questions, please let me know.